Hey, College Math, welcome to our first video for the second half of our quote unquote year in college math. Okay, so we took our midterm, we kind of talked about that a little bit, hopefully. Now we're just going to keep on pushing it, okay? Before we continue with content, we're going to do a little bit more algebra review, okay? We're going to get into a little bit more about exponential growth with some specific cases like doubling time and half-lives. And then we'll get into finance. And in finance, those equations we're going to need to be able to know our exponent properties and work with logarithms. So this is going to help us for not just the last few sections of chapter 4, but then for chapter 5 as well. So hopefully you're looking forward to that. Let's go ahead and talk about lesson D. We're going to look at some exponentials and logarithms. And then in D.1, what we're going to cover right now is we're going to do some exponent properties and we're going to introduce you to logarithms or reintroduce you, okay? So our objectives are to remember the properties of exponents. We're going to kind of run through those really quickly before we get into what we're going to talk about. And then remember, question mark, because I'm not really sure what you guys covered in Algebra 2 last year, because in March we kind of had that's when the pandemic broke out, or sorry, not when it broke out, but when it hit pretty hardly, so we had to stop school for a bit, at least in-person school. And so I'm not really sure how much of this you remember, so we're going to cover it like it's kind of brand new. Okay, so potentially we could be defining the logarithm by relating it to exponentials. We're going to find some values of logarithms, and then we're going to rewrite exponential equations as logarithmic equations. Okay, so first, like I said, let's go into our properties just to remember them, just to kind of refresh ourselves on what those properties say. Okay, so our first property, that's what it's the one where we are multiplying two of the same bases. Sorry, I just said same bases and I wrote a different base. So I have a to the m times a to the n. Okay, what do we do with the exponents? We add them. Okay, so as an example, if I had, I'll just do my examples kind of over here. I'll do them in green so where we can differentiate them. So if I had 6 to the second power times 6 to the fourth power, we would add those. So 6 to the sixth power. And then if we throw that into our calculator, we get probably some pretty big number, 6 to the sixth power. Yep, 46,656. Okay, we can do this with variables as well, but we'll kind of just do some concrete examples. Okay, even though I said 46,656. Okay, so that's our addition property of our exponents. That's when we add the exponents. Now there are cases where we multiply the exponents, and that's when we have, let's say, a to the m, then that raised to the nth power. In that case, we're going to take m and multiply it by n. All right. So if I had, for example, 2 to the third power raised to the second power, I'm not adding those, I'm actually going to multiply. So that's going to be 2 to the fifth, which is 32. Okay. I also have a division property. So if I divide two of the same bases with different exponents, then we're going to subtract the exponents. Okay, as an example, we have 4 to the seventh power over 4 to the third power. So that's going to be 4 to the 7 minus 3, which is 4 to the fourth. Okay, and then 4 to the fourth is 256. Sorry, didn't know that one off the top of my head, and I apologize. All right, so those are kind of the more basic properties, the foundation properties. We have a few more to look at, just 3 more, but I'm going to erase these, so make sure you have them copied down on your paper. I didn't give myself enough space because I forgot that I wanted to do examples as well. We have 3 more that are going to be important for our conversations about logarithms and exponentials. Okay, so I also have what happens when I have a to the negative n. So what happens if my power is negative? Well, typically we like to work with positive exponents. So what that does is it takes the reciprocal of what we're looking at, so 1 over a, and then it makes the exponent positive, okay? So you want to be careful here, and I kind of want to do a little bit of a complicated example just to show you the differences, right? So let's say that I had, we'll use a variable this time, 4 times x to the -2. Well, this -2 is being applied to just the x. It's not parentheses 4x, right? If that was the case, it'd be different. But the -2 is only being applied to the x. Okay, so if that's the case, then I'm only taking the reciprocal of the x term. So that's equal to 4 times 1 over x. Then I make the exponent positive, so x squared. And that becomes 4 over x squared. All right, so it's only taking the reciprocal of the base that it's applied to, right? So just kind of keep that in mind. And then I have what happens, well, if my exponent is a fraction. So let's say my exponent was 1 over n. Okay, well, that right there is the exponent representation of the nth root. Okay, so you know a pretty famous example, 9 to the 1/2 power. Not this specific example, but you know kind of the 1/2 power. That's our good old friend, the square root. The square root of 9 is 3. Okay, but we can have others, like let's say, we'll do another example. Let's say we had 81 to the 1/4 power. That's the 4th root of 81. So what times itself 4 times gives us 81? That's 3. Okay. So that's what the 1 over n exponent does. That's the nth root. All right. And we can have it be a little more complicated. Well, what if it's not just a 1 over a number? Like what if it's not just 1/2 or 1/4? Let's say it was a fraction with a numerator different from 1, so m over n. Well, there's two different ways I can express it. I can either do the nth root of a to the m, or I can do the nth root of a raised to the nth power. These are actually the same thing and will get you to the same answer. Normally though, this is going to be the easier one to work with, so I would probably remember that one a little bit more. Okay, they're both valid, but this one's usually easier to work with. Okay, so let's say I had 125 to the 2/3 power. Well, I can express it like this. Let's see kind of why this would be a little bit easier. If I do it the first version, that's going to be the cube root of 125 squared. But 125 is kind of already big. When you square it, it becomes an even bigger number. So then you have to get a huge number here and then find the cube root. Or it'll be a little bit easier to find the cube root first of 125 and then square. Okay, what's the cube root of 125? That's 5. And then 5 squared, that's easy, 25. All right, so now you kind of see why this kind of layout is a little bit easier. All right. Cool, so those are all our exponent properties. Now that we've kind of remembered them a little bit, let's keep going. All right, so our exponential function. Let me go ahead and erase some of this. Just to give myself enough space. So the exponential function, that's our f of x, is equal to some number a to the x power. Okay, that's our exponential function because our x, our input, is the exponent, right? And there's some, and so let's write that down. X is the exponent, right? That's why it's called an exponential function. And then we call a our base. Okay, and there's some rules on a. A has to be positive. So it has to be a positive number, and then a can't be 0 or 1. Okay, because if it was 0, then it would just be 0, like it would just be f of x equals 0 forever. And if it was 1, it'd be the same thing because 1 to any power is just 1. Okay, so we just kind of get rid of those dumb little cases by putting a rule that says a can't be 0, 1. But then a definitely has to be positive because if a is negative, then this actually is not a function. Okay. So there's our exponential function. And then just kind of some things to remember. Our domain, okay, so what values can I plug in for x? It's any number, so all real numbers. Okay, and then what's our range? There we go. Let me scroll down a little bit. Our range, okay, what numbers can I get out of the exponential? What are the results looking like? What are my y values? Well, those are only positive numbers, so the range is y is greater than or equal to 0. Okay, and you actually can never get 0 either. Okay, so domain and range, we don't really have to formalize them. We just gotta remember that way we know what we're allowed to plug into our exponential and what numbers we get out of it. And that'll be important when we talk about the logarithmic function right here. Okay, so those are the characteristics of our exponential. Now for our logarithmic function, okay, so this is the function that we're gonna be studying for the next week. The logarithmic function is the inverse function of the exponential function, okay? So that kind of will need to review a little bit. What's an inverse function? Well, an inverse function is, when I find the inverse of a function, let's say f of x, what I'm doing is I'm switching the domain and the range. I'm switching the input and the output. I'm switching the x and the y. Okay, so a logarithmic function takes f of x and makes it into, f of x is the same thing as y, so y is equal to a to the x. It switches the inputs and the outputs, so now x is equal to a to the y, but then I have to solve for y, and that's kind of weird because I don't know how to do that. So that's kind of where the logarithmic function came about. It came about to give us a way to solve for this y, okay? So the definition of a logarithmic function is that it's the inverse function, and the way I write it is f of x is equal to log, that's my function, base a of x, okay? So kind of think about the inverse of a exponential function. The input of an exponential was the exponent, and then y was just the result, right? So now the input is the result of an exponential, and my output is the exponent, okay? That's kind of weird to think about, but that's just kind of how it works, right? So let's talk about kind of, if you notice, it has base a, okay? That's gonna be still the same thing. We call it the base, just like in the exponential, right? And it's going to be the same rules. A is positive, and then a can't be 0 or 1. Okay, so let's just kind of let's talk about that really quick. Like, what does this all mean? Well, let's say that we had an exponential equation. Okay, this is not necessarily a function anymore. It's just an equation. So y, let me do it in a different color. Y is equal to a to the power of x. Okay, the way I rewrite that is log base a of y is equal to x, okay? And now you kind of see where this idea of inverse comes in, right? Logarithm is the inverse of exponential, so I switch the input with the output to then create the logarithm, okay? So right now with just variables, it's really confusing probably if you do, especially if you never learned this or if you don't remember it. So let's talk about using some actual number examples, okay? Examples with numbers. So let's take something that we know. 3 squared is equal to 9. We know that, right? 3 times 3 is 9. The way I rewrite that as a logarithm is log base 3, the bases stay the same, so log base 3 of 9 is equal to 2. Okay, so when you take the logarithm, you're pretty much asking yourself, so let's say the way I would phrase this, okay? So log base 3 of 9 is equal to 2. I ask myself 3 to what power gives me 9? And that's 2. Okay, so had I just given you this and I asked you, well, what's that equal to? Then you would ask yourself this question. 3 to what power gives me 9? Because the result of a logarithm is an exponent, okay? So Maybe that's something that you can write down to help you as well. Answer to a logarithm, okay, log for short, is an exponent. Okay, that's always what you're looking for when you're finding the value of a logarithm or the answer to a logarithm, okay? So that was kind of the foundation. That's just our little bit of a setup, hopefully a reminder. Hopefully you kind of at least started learning this in Algebra 2 last year before we stopped in-person learning. And if not, make sure you're coming in for help, because we can't spend too much time on this, but we do kind of need it. And so that's kind of the point of the review. All right. So meet me in the next video and we'll do a few more examples of exponentials and logs, okay?